Welcome back to the class on electrical machine. In this lecture, we are going to discuss about the starting methods of single phase induction motor. First, we are going to see the capacitor run single phase induction motor. In case of capacitor run single phase induction motor, the stator winding is consisting of two windings. One is main winding, another one is the auxiliary winding. The capacitor is connected permanently in series auxiliary winding, nothing but starting winding. We are selecting the capacitance such a way that the angle between the main winding current and auxiliary current is the 90 degree. So whenever we are applying the sinusoidal voltage to the main winding and auxiliary winding, it will be behaving like a two-phase voltage applied to the stator winding. So the rotating field will be creating in a stator winding. So the rotor will be start rotating whenever we are giving a supply to the induction. So one more advantage here is that because of angle between the starting current winding and main winding current 90 degrees, the backward flux is zero. The interaction between the forward flux and backward flux will be not presented. The pulsating torque developed in induction motor also will be zero. So this type of motors are giving a smooth, silent running motor. It is a good power factor. Efficiency also will be higher. But here the main thing is that capacitor is connected in series with a starting winding at the time of starting as well as the running. The capacitance will be selected such a way that it gives the best starting running conditions. Speed torque characteristics are stored in it. This type of motors we are using only where the places requires very silent, nothing but hospitals, offices, classroom, theaters. Ceiling fans also we are using, in which the value of capacitance varies from the 2 to 3 microfarad. Shaded pole motor. The shaded pole motor, this is the cut section of the shaded pole motor. This is the stator frame. For the stator frame, the projected poles are attached. This is the squirrel cage rotor. The shaded pole motors are very popular for rating below the 40 watts because it is very simple construction. This is the cross-sectional view of a shaded pole motor. So this is the projected pole which is attached to the frame. Again, this is the projected pole attached to the frame. This is the field winding, nothing but a stator winding. This is also the stator winding. So these two stator windings are connected in a series. We are applying the there is no change in the construction of the rotor. Here the rotor is a squirrel cage rotor. So one more important point to what you are observing here is the off portion of the pole will be shaded with a short circuited copper coil. This is nothing but a shaded coil. The same manner this pole also will be shaded with a short circuited copper coil. So because of this short circuited copper coil which is placed in the off portion of a pole, due to which the flux will be moving from the one place to the another place. When you are going to apply the sinusoidal voltage to the stator winding, that moving flux only creating a starting torque in a shaded pole motor. See here we have taken the sinusoidal voltage which is applied to the stator winding. This is a positive cycle, this is a negative cycle. We have taken the 3 points, one is A, B, C. This point we can take it as a origin, that we can take it as O. So whenever we are applying this sinusoidal voltage to the stator winding, the current also the sinusoidal, the flux creating from the stator winding also the sinusoidal. From 0 to A, the current is increasing, the flux is increasing. So there is a rate of change of flux linkage with a shaded coil. There is a voltage induced in the shaded coil, which drives the current through the shaded coil. Because of the current, the flux will be creating. That is the opposite, the very cost to produce it according to the length. In this area, the flux will be decreases, whereas in this area, the flux will be increases. This is the first case. In the second case, when the current is changing from A to B, there is not that much of change, almost constant. So there is no change in the current. There is no rate of change of flux linkage with the copper coil. So there is no voltage will be induced here. There is no current is passing through the copper coil. There is no flux, which is opposite to the main flux. So the flux will be uniformly distributed throughout the pole. Now come to the third case. From B to C, the current is decreasing. Whenever the current is decreasing, it will be decreasing. There is a rate of change of flux linkage with the copper coil. Again, the voltage will be induced in the copper coil, which causes the circulating current through the copper coil. So whenever the current is passing through the copper coil, the flux will be creating. That is aided with the main flux. Because because the current is decreasing, the flux is decreasing. According to Lenz's law, whatever the flux is creating from the copper coil, nothing but shaded coil, that should be added with the main flux. So in this area, the flux will be increased. During the positive cycle, from figure 1 to 3, if you observe means, the flux will be moving from the unshaded portion to the shaded portion. During the negative cycle, again the flux will be moving from the shaded portion to the unshaded portion. Nothing but the flux will be moving from shaded portion to the unshaded portion, unshaded portion to the shaded portion during the positive and negative cycles of the input movement. So because of that moving flux, there is some amount of starting torque will be developed in an induction motor. This is the basic principle of operation of a shaded pole single phase induction motor, so that the rotor will be rotating. These are some of the characteristics of a shaded pole single phase induction motor. The silent features of this motor are extremely simple construction and absence of centrifugal force. The starting torque, efficiency and power factor is very low when compared to the remaining all split phase induction motor. It is used very low power rating where load requires only the 40 watts. Some of the applications where we can see this type of motors are the small fan, coil, hair dryers, desk fans. Now let me come to the AC series motor. In the name itself, it is very AC series motor. AC series motor is nothing but we are giving AC supply for the DC series. Because the field winding is connected in series with the armature, the current is passing through the field winding and armature. So whenever you apply the sensor voltage, during the positive cycle of the input voltage, the current is one direction. During the negative cycle, the current will be opposite direction. So the direction of the field current will be changes. At the same time, the armature current also will be. So the unidirectional torque will be developed in AC series motor will be rotating. There is no difference between the construction of the DC series motor and the AC series motor. But only thing is, if we want to use the DC series motor as a AC series motor, where we are applying AC voltage means we have to do some construction modification so that we are getting the good efficiency. This is the laminated stator core. This is the core on which we kept the field winding. This is the armature winding. This is the commutator. These are the two other brushes. This is the shaft. Field winding and armature winding is connected in series. That we have shown here in a wiring diagram. When the motor is connected to the AC supply, same alternating current is goes through the field and armature winding. The field winding produces a alternating flux that reacts with a current passing through the armature winding, so the torque will be produced. Since both armature current and field current are simultaneously changes, the torque produced in a series motor is a unidirectional motor. The torque always acts in a same direction. It may be noted that no rotating flux is produced type of motor. So when you going to use the DC series motor as a AC series motor, we have to do some construction design changes so that we can expect the more amount of DC motor. So what are the changes we are going to make it? The entire magnetic circuit should be laminated to reduce the core losses because this motor will be operating as an AC supply. The series field winding has a less number of turns when compared to the DC series motor because we are applying AC voltage. It has along with the resistance, it has a reactance also. To reduce the reactance, to minimize the voltage drop in series field winding, so to decrease the number of turns in a series field winding when compared to the DC series. High field flux is obtained by using low reluctance magnet. So we try to use the low reluctance magnet while you are constructing the motor so that the flux will be more. When compared to the DC series motor, in case of AC series motor, there is a considerable spark will be appearing between the brushes and use the same DC series motor as a AC series. These are the different applications where we are generally seeing practically also high speed vacuum cleaners, shaving machines, electric showers, drills, machine tools. All these motors are coming under the AC series motor. Thank you very much. If you have any doubt, you ask me directly or you can ask in the comment box of the YouTube channel so that I am always welcome to answer all your questions.